Hey folks, CeeLo Green here, and this statistics lesson is a review for your test on Chapter 11, which is on t-test inferencing for the mean, okay? So let's go ahead and get started with this, you guys. So the one sample t procedures do inference. Well, inference just means study about a mean. So two sample t procedures compares two means. I have examples of both of those, and matched pair studies uses one sample procedures because you first create a single sample by taking the difference of the response with each pair, okay? Have example of all those. So these T procedures are among the most common methods of statistical inferencing because we're usually not given the population standard deviations, okay? So if you were given the standard deviations from the population, you'd be doing a Z inferencing test, okay? But since we don't, we do a T, and that's most of the time you do that. So the T procedures require that the data be random samples, and that the distribution of the population or populations also be normal. So if they're not, then we got to do some, checking the samples, and if they're not, if you don't know that, and if you can't regard your data as random sample, the result of your inference may be little of value. Okay, so we'll talk about that. So in this chapter, you must recognize one sample studies, matched pair studies, and two sample studies. Okay, that's all coming up. A study investigates whether time perception and indication of a person's ability to concentrate is impaired during nicotine withdrawals after a 24-hour smoking abstinence. Now, if you don't smoke, please stay not smoking, you guys. I hear that is more addicting than heroin. So stay away from cigarettes, you guys. It's just a money drain away from your health and from you. And anyway. That isn't what I'm supposed to do. So after a 24-hour smoking abstinence, 20 smokers were asked to estimate how much time had passed during a 45-second period. Suppose the resulting data on a perceived elapsed time in seconds were as follows. Okay, so you're going to put these two numbers in lists. I'm sorry, not these two numbers, these 20 numbers in a list, okay? So there they are right there. So we're going to compute the sample mean and standard deviation. So go ahead and pause the video and then put that in list 1 and do a one variable statistics, okay? And when you do that, you should get that, okay? So here's my sample mean and here's my sample standard deviation. Make sure you're getting all of that, you guys, all right? All right, so now consider this to be an SRS. All right, so good. So it's a simple random sample of our population. So the study wants to determine whether smoking abstinence tends to lead to elapsed time being overestimated. So follow the inference toolbox, okay? So now up here, key thing up here, it says we're asked to estimate how much time had passed during a 45-second period. So my null hypothesis is going to be equal to 45 seconds. And my alternative is going to be greater than. It's supposed to be impaired, so the impaired part is going to make it greater than, okay? So step 1, the claim is about the population of smokers and the perceived elapsed time for these who have not smoked for 24 hours. So the null hypothesis is 45 seconds and the alternative hypothesis is greater than 45 seconds. Alrighty. Step 2, because we don't know that the population standard deviation, we're going to use the one sample t-test. It states that this is an SRS from the population, so we're safe to proceed. Okay, I'm a little bit cautious on that part right there. I don't remember seeing the word normal on there, so you might want to state that as well. I'm going to go back. Let's see. Yeah, I don't see the population being normal, so I'm guessing it's the whole population, you guys. So if it's the whole population, then definitely it's normal. Okay, and since it's 20, depending on which textbook you use, your central limit theorem may normalize your sample. But it did say it was a simple random sample from the population, so we're safe to proceed. Okay, so step 3, go ahead and carry out your t statistics. So this is my formula, the sample mean minus the population mean divided by the sample standard deviation over the square root of your sample size. Okay, so plug all that information in and I get 6.50. That's what t equals. Okay, so since n was 20, my degrees of freedom is 19. So go across your degrees of freedom in table C on 19. Go way across and look for the 6.50, and I think my degrees of freedom is, let me see, here's my book right here, hold on right there, I'm going across table 19, sorry, my thing hit right there, and I get, as I go across, I'm looking for the 6.50, and mine goes to, actually it's 3.883, not 3.85, 3.883. Okay, it only goes to that. It doesn't even go to 6.50, so 6.50 is way out over here right there. And so if this is 0.0005, which is 0.05%, it's even less than that. So you can say it's virtually zero. Okay, so because a sample gives a p-value that's less than 0.05%, this gives very strong evidence to reject HO. So your conclusion is there is convincing evidence that the mean perceived time elapsed is greater than the actual time elapsed of 45 seconds. It'd be very, very unlikely to see a sample mean and hence a t-value that this extreme just by chance if HO was true. Okay, now just to recap on this, if we made a mistake, you guys, okay, so this is just for good measure, if we made a mistake, and I'm almost positive we didn't make a mistake with that small of a p-value right there, in fact it was even way smaller than that, much smaller than that, I'm pretty sure we're pretty good enough to reject it. But if we did, it would be called a type 1 error. Type 1 error is where we reject our null hypotheses when we shouldn't have. So we would have decided that the smokers who have not smoked in 24 hours do overestimate the elapsed time when they really don't. Okay, but I'm positive we didn't do a type 1 error, but that would be the case. And the type 2 error would have been, we would have concluded there was no evidence that the smokers have not smoked for 24 hours, overestimated their elapsed time when they really do. Okay, so just a review on that, and it looks like I need to put a little space in right there. I'll take care of that right now. Okay, hold on. Never mind that man behind the curtain. Okay. Alrighty. Oh, did you ever see that cool movie? Okay, so here's another one, you guys. Are women still paid less than men? So one study collects random samples of men and women who worked for the Mayberry Enterprise. Salary data were much larger. So the data were much larger, but this data is consistent representation of it. So here we go. So go ahead and put those in list 1 and list 2 for us, you guys. I did that, okay, for the men and women right there. Okay, and these are in thousands of dollars right there. Okay, and the study suggests that the samples to be representations of the two populations of interest in a managerial position, using the sample data to determine if there is convincing evidence that the mean annual salary for male managers is greater than the mean annual salary for females. Okay, so step 1, we want to use this data from the samples to test the claim that the mean salary for males is greater than the mean salary for females. Okay, and the population characteristics of interest are the first mean is the mean salary of men, and the second mean is the mean salary of women. Okay, and so this is a two sample statistics. We want my null hypothesis is sorry, I was looking at my TV, is that the means are equal, that there's no change. And my alternative is that they're not equal, that the men's is greater than the women's right there. Okay, so we're going to go ahead and test that. So since these represent an SRS of the population, and since we're not given that the population standard deviation, we're going to do a two-sample t-test for the difference in the population. All right, but because the sample sizes are small and we're not told the population is normal, we better check to see that these samples appear normal. So I'm going to create a back-to-back stem plot of these, you guys. So there's my back-to-back stem plots, okay? Whoops, I think these numbers go down, you guys. In fact, I know they go down. Where's my paper here? Yeah, they go down. Sorry, this goes down right down to... boom, right there. Okay, sorry about that, you guys. Okay, so now this side, it looks like it's slightly skewed to the right here. This side looks pretty symmetrical, and so what I'm doing is, if I could, turn this 90 degrees clockwise to look at this, you guys, and then turn this guy, you know, counterclockwise if you want. Just take a look at it as it's standing up. This one looks like it's skewed to the right because it has a little bit bigger of a tail, but not much, you guys. It's slightly skewed to the right. So they're both roughly symmetrical with no clear outliers. This one definitely looks bigger than this one, but when you look at them separately, this one's symmetrical or roughly symmetrical, maybe skewed to the right a little bit, and this one's pretty symmetrical right there, okay? All right, so I can go ahead and proceed right there. So there's my t statistics for my 2 sample. Okay, and so I'm going to plug in the values because I calculated all those values with my 1 variable stats right there, and I get my t equal to 3.11. Okay, now since both sample sizes were 10, then my degrees of freedom is 9. And now if they were unequal to each other, we always take the smaller degrees of freedom. But they're both equal here, so it doesn't matter. So scroll over your degrees of freedom of 9 and find the t values that that's surrounding this 3.11. And I see the t values in my row of degrees of freedom of 9 as 2.821 and 3.250. And then go straight up and look for the probabilities. I get us between 0.01 and 0.005. Okay, this is 1% and this is a 0.5% right there, 0.5% right there. Okay, so step 4, interpret that, you guys. So with the p-value less than 0.1 or less than 1%, sorry, then this is statistically significant evidence to reject your null hypotheses and that the mean salaries between men and women that the mean salaries are equal. So we can conclude that the mean salaries among the men is greater than that of the women. Alrighty, that should be good enough, and then your test questions will be similar to that, what I just did, and similar to that homework assignment right there. Take care, you guys.